everyone. Welcome to our Machine Learning Best Practices on Digital Hub webinar. We are so excited to have you all here. This webinar is part of our Oil and Gas Data Science and Digital Hub series. Before we get into the presentation, I just want to draw your attention to our legal disclaimer. Material presented here, including but not limited to text, images, and codes, are subject to Digital Hub terms and conditions and are for demonstration purposes only, and may contain future product features and plans. Sharing, copying, reproducing, and modifying them in any form requires Integra's permission. So I am Hoda Rezai. I'm your host today. I also have Babak Shafi, Integra's founder and CEO, with me, which is going to walk you through an introduction of Integra and Digital Hub. And I also have Sylvia Lee, our data scientist. So what you expect during this webinar is an introduction of Integra and Digital Hub. And then Sylvia will give you an overview of the machine learning best practices. And then you will see these best practices in action on Digital Hub. So we have planned one upcoming webinar for you on May 18, which actually be the part 2 of this machine learning best practices on Digital Hub. So tune in, and you can register through our LinkedIn page and also the Eventbrite page for this webinar as well. I encourage you to join our platform Digital Hub to be able to follow along during this webinar and also access the notebook and data afterwards. So it's in 3 easy steps. You need to register and sign in at cloud.digitalhub.io. Then you need to be subscribed to a plan. It's either academia, individual, or teams plan. We are offering academia plan for free to students and also to our event participants. You can use the DigiFuel promo code to qualify for the free plan. Then you need to create a project, either a machine learning or a data exploration project, to be able to access the notebooks and the data. But Sylvia is going to walk you through it on the demo as well. And with this, I'm going to hand it over to Babak. To you, Babak.
Thank you for the introduction, Hoda. Good day, everyone. I see, just looking at Google Analytics, I see everyone from around the globe. So good day to people in Latin America, to North America, to Europe, to Russia, and to east part of the world. So welcome, everyone. We're very excited and very humble. I think over 2,000 people signed up for this event, but obviously we don't have as many seats to accommodate everyone. So those who are here, I hope that you find this event valuable to you, and make sure that you sign up for the second part of this event to take full advantage of it. Just a little bit about Integra and the company and the philosophy. We are a small boutique company in Calgary, Alberta, in Canada, focused on oil and gas. I have been in the oil and gas industry for the last 10 years as an executive, and also spent 10 years in consulting with IBM and Deloitte as a senior manager, rolling out analytic and data solutions. I'm very passionate about data. I love what AI and ML can do for our industry. And I've started Integra last few years to enable have real world experience around solving problems when it comes to pipeline integrity, to health and safety, to upstream optimization, production optimization, gas optimization, drilling optimization. We've done it, and we're actually sharing a lot of what we've done to everybody else, because we truly have a vision of changing the industry and getting the industry to use more of the data that they've been accumulating over the years and use AI and ML. So very focused on AI and ML. Our platform, Digital Hub, that you us to share what we have. I won't have a platform. Promo code that we have today to sign up for it and look at the templates and the best practices around well log analysis, from predicting failures, and so on and so forth, in order to really catch up with this technology. We made it very easy with Digital Hub for anyone to quickly set up a platform as a small team, a large team, or even an enterprise. And if you are an enterprise listening to this video, or you're on this webinar, please don't hesitate to reach out. Our platform works on any cloud. It works on internal, external cloud, private, public, and we're happy to help you with that. So that's much about Integra. Check out our use cases on integradas.ca. That's where we keep our consulting side of the house, and we are happy to share what we have done, because I truly believe the only way that our industry can progress is that we do have more of examples. There's a lot of good education that is coming from around the globe around what is AI, how to use it, what is ML, and what are the best practices. We kind of take all of that and apply it to a specific problem, such as forecasting or predicting a pump failure. So how do you actually bring best practices into the life of a solution and with a methodology? Our team consists of engineers, data scientists, and other people who are very passionate. So we do a lot of this work out of passion, and we love it. We can't wait to do this. We're gonna have more webinars. With that, I'm going to pass it on to Sylvia. She's got lots of good material prepared, spent lots of time to think through, her experience and share some of the best practices. I'm sure most of you are joining also have ideas and best practices. We have a community that you can join and you can share. This is Integra sharing with you, and we're hoping that you will share with us back through the community. Thanks, everyone. To you, Sylvia.
Thank you, Babak. Hi, everyone. So I'm Sylvia, I'm the data scientist here at Integra. And so today I will be sharing with you just something that we have seen working in Integra with different machine learning and data science projects, some oversights and advices that we have summarized from our experience, and then also summarize overall what is the iterative process that we have personally gone through on our use cases in terms of machine learning processes. And then we'll be going into the demo on Digital Hub in terms of after we've summarized everything about this, what did we do on Digital Hub to make it easier for everyone else to get started off on the right foot when you start a machine learning project. So just two big oversights are something that we've seen people often get distracted sometimes when they go into a machine learning problem. Because machine learning, AI, these big hype words is very exciting. But it's most important to don't lose sight of what's important. Data science is called data science because data is the most important part of it. It's not called model science for that matter. So what you want to do when you start off in any sort of data science process or looking to get insight out of the data, remember that it's the data that's the most important. You want to make a model that works best with your data, that gives you the best results from your data, not the other way around. If your data doesn't work well with a neural network, there's no way you're trying to force your data into a neural network. And also your model, they really only perform as good as the data you give to it. So there's this very cliche saying that a data scientist spend 80% of our time on the data, data cleaning, data wrangling, data feature engineering, all of these things with the data, and then we spend the little 20% on the model. And that's actually very true because the model, there's only so much you can do with a model optimizations and model selections. Ultimately, what's going to give you your best result and best insight is if you prepare your data good enough for it. The second big important lessons that we've learned is that you want to know what your objective is. And this, what I mean is that when you come into a big business problem, it's generally very grand. You're trying to optimize something. But often, very often where machine learning comes in, especially when you're just getting started, is to actually target a small part of this big business problem, a small but critical part of it. So then you can see the most values are. So setting no value. Sometimes simple can give you the most critical value that you're distracted in this very big cloud of a problem that you're trying to explore through. So know your business problem, explore your business problem thoroughly, and then find the most critical parts to work with. So that's these are 2 big oversights that we have summarized from our experience. So now knowing the objective, now it goes into defining your problem and defining the data science parts of it. So when it comes into that, we've also summarized that into 4 big categories. So when you try to explore out and actually map out your data science problem, you first want to know your data. So what are the features and variables that you have in terms of what you're trying to predict or cluster? Do you have the critical features? So this is oftentimes where the data scientists will have to go in and communicate with the subject matter experts, get their advices in terms of like what kind of features engineer that I might need to do. Am I missing anything? Do we have labeled data? How much data you have? Is the data structured or non-structured? So knowing all of these comes into helping you decide what type of model you want to start with. So now in terms of model, are you going to with classifications? Are you doing clustering? Are you doing regression? Sometimes doing this part is also where we're going to start to think about how do I assess the performance of my model. So am I just gonna go with simple accuracy or root mean square? Is that good enough for me? Or is there other metrics that might be more important? Say in a classification, is false positive or false negative? Maybe one of those is more important than the other. And the third part that we have is sometimes very often forgotten when you get started on a data science project is the ethical part of it. So with data, there's a lot of ethical concerns now coming into data science, especially you need to know if your data is sensitive to aggregations. Is it going to pose any ethical concerns when you present your results? The way you gathered your data, was it ethical? Do you need to do any sort of ethical practices or like transformation on your data before you can go on forward? Because that actually might affect the performance of your model. You might have to actually give up a little bit of performance on your model in order to actually make your whole product an ethical product. Now with the product, you also want to have a good vision of it. What I mean is that you don't have to know exactly in the IT infrastructure where it's going to be deployed or what you're going to use to deploy, but you want to have overall the values on the final product. So is your product going to be doing real-time predictions or batch predictions? Is it going to be a prediction time? Is that going to be a critical factor? Are you going to have computation bottleneck? Is that going to be on cloud or on premise? Where are you going to deploy that? So all of these questions, I guess, considerations, then like all built into how you set off your roadmap to start exploring your data science problem. So now next into the more categorize it into 3 big iterative processes. By no means are these processes independent from each other. It's just overall in our experience we've find that it falls under these 3 umbrellas. So we usually first start off with the exploration stage. That's where you're trying to map out your problem and then do some data exploration. Maybe communicate to the subject matter experts with what you found on the data, and then maybe try to redefine your objectives a little bit more to make it more specific, or even take a completely different turn. So there's a lot of this back and forth during your exploration stage. Once you have mapped out sort of a roadmap for your model building, then I would go into this another loop of feature engineering. So trying to get the best data for your model and then optimizing your model, maybe finding out, oh, maybe my model is not performing quite well because I'm missing some features, or maybe some features is not the way that it's presented in the data set is not the best way that the model can learn from. So make a lot of this back and forth between the feature and your model optimization. And finally, when you have your model ready, maybe for its first deployment, then it goes into the growth of the model. So a model, machine learning, they can learn. So this is the attractive part of machine learning models, right? So when you actually deploy your model, you're gonna get more data. When you get more data from your production, you can integrate that or put it into your training pool, retrain your model, let it grow, and then redeploy it. So there's a lot of the cycle again between like training your model and usually that also means going. That's what I meant by these cycles. They're not completely isolated from each other, but overall, you can And because of this iterative processes, all of these iterations, it becomes really important in terms of how we get started on the development. You want to get started in a way that to ensure that when you go through all of these repetitions, your environment is always consistent. You have a very good documentations on your progress. You have version control in terms of like how you can keep track of all the changes to your models. So then there's a lot of these best practices that we would keep in mind when we get started and actually set off on the data science project development. So next, I'm going to show you how we integrate a lot of these best practices into our Digital Hub platform to help you get started on your data science project easier. So just let me switch screen here quickly. Just 1 second. I'm going to switch it to my browser here. It's going to show you Digital Hub. So what you will see here is Digital Hub sign-in page. So if you don't have an account with us, you can always come in at cloud.digitalhub.io. It will bring you to this sign-in page here. Click on the little sign up button here and just put in your name, an email, and then you can come in and sign in with us, get an account. So I'm just gonna sign in here for the demo. Sorry, the project. So we go to home page here. So this is Digital Hub. So in Digital Hub, we defined all of these as projects. So a project is kind of like the units that we manage on Digital Hub here. So what you will need to do after you register with us is to actually get a subscription with us. So if you go under subscription and into pricing, this is where you can subscribe to different tiers on the platform here. And as Huda said before, we are offering the free subscription out to all of you with the promo code Digital Hub. So if you just click on the Selection Academia, I'm not going to downgrade for the demo, but after you click into the select there, you'll be required to enter that promo code and actually give in a little bit of your payment information. That's just for you to easily buy if you need to top off hours or any of that on the platform. So the next then, like after you have a subscription, we can go ahead and create a project. So in this case, because we're talking about machine learning, I'm going to choose a machine learning project to go with. So next we have several components that's already integrated onto the platform. So we have H2, which is actually auto ML, and integrated with Jupyter for just auto ML machine learning. And then we also have Superset and Grafana for visualization and dashboarding. If you have a team subscription, you'll be able to add members into your team project. So let's say this time I can add Hoda. We have different roles associated with the projects that you can manage the permissions for each of these users. And then the last part will just be creating a project. So I'll say this is a ML best practice. So give it a good description. Give it a tag. I'm going to give it a ML machine learning tag so I can find my project easier later. So after you've launched a project, you can see that there's all of these are being provisioned. So what's actually happening in the backend is that we're provisioning a database for you that's going to interlink all of these components together as a single source of truth. And then we're also deploying an instance of each of these components for you in your project. And they're all separated. Say you have different projects with Grafana, but those are actually going to be different Grafana instances in the cluster just to keep your project segregated from each other. But while we let this go, we have a project that's already prepared for the demonstration here. can see I have my other components post. You can manage Jupyter here. So this is where I'm going to that help you get started on this machine learning journey. So with the create a conda environment for that project that we need. So that environment keeps track of all the packages that we have used on there. Breakdown because some package operates. And then so the way that we have facilitate that on the platform here is with the conda environment. So then with the conda environment here, you know, which then allows you, of course, you can, but just very can create a new environment is being created here. I have a demo for this inside the terminal here, and I can go in and click on this little button here to start installing package that it shows. We have integrated into the install. So this is a repository of the different managed by the Git extension. You can also manage the history in here. So in this case here, you can see the changes is a view of the you can also see a commit history in here. You can also pull and push from a remote repository if you have already set up with it. If you're just getting started on a new project, you can Git tab here to initiate remote branch. So those are two quick tools that we have integrated. Started on machine learning on the right foot. The next thing that we have on here is just a notebook on some data science feature engineering that we have on here. So I'm just going to quickly run the notebook. Notice I actually changed my kernel into my demo conda environment here. So this is just to another emphasis on like how we can use conda environments to kind of keep all the same environment. Electricity generation problem. So we're trying to predict the power generations from a combined cycle power plant. Data set that you can add in here. I'm just going to show you very quickly. If you have been in a previous webinar, you'll be familiar with this very quick data exploratory analysis wise on all of our variables. So this is where the first stage of data is to know your data set here. And this being a sample data set, we don't have any missing values or any outliers, which is amazing. But so you can also get the very quick interactions between all of your data here, and also see a very quick correlation. For more details of this, you can see our data exploration webinar from before. But the first thing that we'll do in any data science is to split up our data. So we need to abide to what is called a golden rule, where in simple term is that the data that you validate your model on and do the final performance analysis should be data that your model has never seen. So this is why we always need to start splitting up our data. The common case here is to split them up into a training, testing, and validation set. The validation set is something you're not going to touch until the very end, whereas the testing set is kind of what you're going to use to evaluate your model during that whole cycle of model building. So between the feature engineering and model optimizations. So in this case, I've split up my data into my training, testing, and validation sets, on cross-validations that we might talk more about in the next webinar series. But just to showcase this golden rule, we're just going to go with this simple splitting process into the 3 different data sets. So now into feature engineering. So I think one of the very important, 2 main important points with feature engineering is that different way your feature is presented to them. So sometimes this might be means that you have to apply certain transformation. The second, this is actually going to affect your model performance quite. Comes very important in feature engineering is to remember that whatever transformation you applied on the training data set is the transformation you're going to apply on your testing data set. On my data set, using the maximum, I'm using the maximum of my training set. And then when you transformation on your testing set, you're still using the maximum from your training set, even though the maximum here, say I'm using the maximum from the training set here for that standardization. So this becomes very important to mention that you have to carry on all of your parameters and your where I build transformations. So I have a field normalization, standardization, and extract. The features that is applying the transformations to, what are the parameters of the transformation? This is for your reference in here. So it's just very quick class object in which we can apply pip9 to and a transform function. So flipping will be on my the pipeline that I fitted from my training set to my testing and validation set. Did a of my numericals, and then I extracted my date time into the month, and then also categorized the date into, is it the beginning of the month, middle of the month, or later on in the month, and then applied one hot encoding to it. So with more but just to showcase a little bit more with model where it's a distance-based algorithm, normalization, standardization becomes very important. So then I can see in here when I've trained up a support scores is only about 0.3, whereas after I've transformed it, the score increased significantly. This just to emphasize the point that where the feature this transformation as much. So these can include so decision trees model. So this is just so the final quick summary on the scores that we have in here. Almost out of time here. So then we have already got into the model optimization part, which can the rest of the notebook here goes through how we evaluate the model fit. So in this case, I have my SV or SVM highest score, So of my testing data sets, so this is the model that I'm carrying on for. Just grading, usually how we look at it is usually clustering around zeros. Might be some of the features that we go into and see, is there something wrong with our feature engineering, or or maybe it's just a optimized of assessment that we can do is to do a we want to make sure that like all of these residuals outliers is probably what's corresponding to these deviations here in the tips here. But you want to make sure that your residuals, they are pretty much normalized around 0 here. So that was performed on a training and testing set. So now let's say this set. So this is data that it has never seen before. So I again apply the same transformations to my validation set here that I fitted from my training data, and then so this is what energy output, and just summary of 0.92, which is actually pretty great. And then here just comparing our validations just comparing our we can see that like they're very well on here with our in this comparisons here. Staying with us for this extra minutes. This marks kind of people that rush through the notebook very quickly, but we will be having this notebook up in our templates notebooks inside more details of the feature engineering. We've also added a few resources, to a few links and blog posts that explains and also in terms of different machine learning models that you can go in and read. But overall, just want to thank you that you enjoyed the demo. So I'll pass it back to Bharat.
Thank you, Sylvia, and thank you everyone for joining today. The conversation doesn't stop here. Please, like I said, either join the class, prove it, and use it, publish your thoughts and your best practices, and let's help each other grow this practice and this kind of sharing across the oil and gas. Lots of talented people, lots of really good engineers who are trying to transition from their expertise into oil and gas, and this is exactly what we need at this moment. Everyone, and we'll see you soon again in May with additional webinars. Thank you.